4 inventors in history know of what I'm about to tell you, and yet this is like 100 years ago, and we don't know about it anymore. I haven't seen it in all of my readings, and I'm just largely self-taught. I didn't take any formal education in electrical engineering, but I don't see this anywhere. So I have to tell you what I'm telling you is probably not very well known, so you'll just have to take it on faith or whatever, because that's just the way it is. The 4 inventors I speak of are Edward Leeds Skolnin is one, Nikola Tesla is the second one, Nathan Stubblefield is the third, and the Amman brothers is the fourth. Now I can't say Oliver Heaviside knew about this, so I have to leave him out of the picture. He does know about half the story. This we know historically, but I don't know if he knows this other part that I'm about to share with you. Now, what I'm about to share with you is the AC version of magnetic flow. Now, we all know about DC and AC of electricity, you know, and we also know about the DC version of magnetic flow. We know about it, it's called magnetic remanence, and it was utilized in computer memory banks dating from the 1955 to 1975 era. Excuse me. And we also know about Edward Leeds Skolnin's popularization of what is called the perpetual motion holder, which is basically a iron toroid, and you put a DC current in there using just an instant of energy sent through copper wires wound around the toroid, and just for an instant, and it can be in there for ages, and it won't diminish. But that's DC, that's not AC. I'm sorry, I'm a sickly person. That's my excuse for coughing in your face. Anywho, so what I'm about to tell you is the AC version of magnetic flow, and it's a riot, it's a real rip. And we get the hint from Edward Leeds Skolnin. This is the guy who gives the hint away, but nobody got it yet, and so I'm giving it to you now. In his book, Magnetic Currents, he talks about little monopolar magnets that travel around in opposite directions. And he says one is a north monopole of magnetism without a south pole. So it's a monopole. It's not a dipole. It has only one pole, and one of them is north and the other one is south, and they go in opposite directions simultaneously. Sorry. Now, regardless of whether or not he specifies where they travel, I'm going to tell you something that is very ridiculously unsettling at first until you finally get the drift of the implication. It's true it doesn't matter the medium in which they travel, in a sense, because they exist in all mediums of traveling. The difference is, if you change the medium, the substance, it changes the behavior radically. And it's not a source of free energy, it's a source of understanding about how free energy fits into the universe. And that will be how I terminate this recording, in how I piece it all together. So, bear with me here. I'm sorry. Yeah. Every time I eat, I have to cough. Well, it belies my age. I'm not a young snapper. Okay, enough of that. So, when we have AC in a copper wire, it alternates. We're all familiar with that. The alternation of voltage polarity in a copper wire induces current as a side effect to also try to catch up to the change in voltage polarity that happens, 50 times a second in Europe, or 60 times a second in the United States. And we know from Jim Murray that if you double the frequency of the line voltage but don't change the line voltage amplitude, the power quadruples. He's already done that experiment, and I've seen it happen under simulation many times. So it's a very interesting phenomenon. And it indicates to us how important it was that Nikola Tesla won the AC war over Edison promoting DC, because AC is more efficient. You can get it to do all kinds of things because now you have frequency to play with, while with DC there is no frequency component. It's just voltage and amperage and resistance, and that's it. But when you have frequency in addition to the other stuff, now you've got phase relation, and you've got all kinds of extra factors you never had before. And it helps give you more tools to play with to help you do whatever it is you're trying to do. So we know the value of AC. Our universe, is run by AC, and we only use DC when we have to, like powering a computer, for instance, or powering a flashlight. But AC rocks, okay? So we know that. Now, when we get to magnetic flow, though, we still are quagmired in this ancient theology that it has to be DC oriented, and that's the best we can do. That it always flows in one direction, and that's it. And it's bogus, because there is more to it than that it is capable of, and it's very different and unique. So let me back up a bit. Now, when Michael Faraday discovered the effect of electricity traveling through a wire, creating magnetism as a side effect, or for that matter, passing a magnet over a piece of wire, creating electricity as a side effect, he was just scratching the surface of what I'm about to tell you. But it's okay, he got us started. So I'm going to take it one step further and explain that a little differently. So what I quoted is his experiment. If you send electricity through a copper wire or any other conductive medium, a metallic wire usually, magnetism is the side effect. But if you pass magnetism across the wire, electricity is the side effect. Now let's change that situation just ever so slightly and see how things really get interesting. If you pass electricity through copper, magnetism is the result. But now, when we want to pass magnetism across a metallic surface, let's not choose copper. Let's choose iron. And now, when magnetism flows through iron, eddy current is the result. And that's what we call the electricity that is the result when it occurs in iron. It has a specific term. It's not just electricity, we call it eddy current. And normally we try to get rid of eddy currents by breaking up the metallic substance, the iron, or the magnetizable substance, by either creating what's it called when we make plywood, a composition in which it's not all iron now, it's got other materials mixed in to break it up so that the eddy current doesn't go very far before it hits its head up against an insulated material. See, it's like a matrix. The iron particles are embedded in, and they press it together to create the core for transformers, so that when you take away the power suddenly ceases to exist. And so you can't use modern day transformer cores that you get on Amazon for perpetual motion holder experiments because it's not solid iron. It's a composition of iron and other insulative dielectric materials that blocks the flow of eddy currents, so that when you take away the power source, the eddy currents stop immediately, and so does the magnetism as well that created those eddy currents. So that's one way to deal with eddy currents. The other way is to break up the iron and make plates out of it and insulate the plates so that when you stack them, the eddy current only travels within each plate but doesn't travel between the plates, and so you localize the eddy current that way. And that's the way armatures to motors are. They're a sandwiching of iron plates that are, in the shape of an O, let's say, or a C, and they have a certain width to them, and then they stack them to make a block so that it's a kind of like a square block that's toroidal-like in shape, but it's a composition, again, of plates. Well, there's another way to deal with eddy currents, and this is what really brings things to a head. It's something you can do with magnetism that you can't do with electricity. So let's back up a bit. If you send current down a wire, two currents, excuse me, if you send two currents down a wire going in opposite directions at the same time, they neutralize each other. They're still there. The power, the amperage is still there, but the wattage is zero. Okay? Now I'm talking AC, okay? So it's the same cycle, 60 cycles. Each one is 60 cycles, and they're in phase, except they're out of phase by 180 degrees. Now this is current now. I'm not talking about voltage. This is just two currents being sent down the wire in opposite directions simultaneously, same in phase, same frequency. They neutralize each other's power. So the wattage is zero, but the current is still there. It creates a standing wave of current, unfortunately, and it fries the wire. Because the wattage, what wattage means is the loss of power from the wire being transferred to its environment. And if the wattage is zero, that means there's no transference of power. All of it is stuck inside the wire, and it's going to fry itself because it has nowhere to go. Sorry, now maybe that's the last one. Hopefully. So we don't want that. So what do? We don't send current down a wire at the same time in opposite directions. We alternate. Every half cycle, every 120th of a second in North America, or every 100th of a second in Europe, we send first one direction, and then we turn around, and the next 100th of a second in Europe, or the next 120th second in North America, we send it in the opposite direction. That way we get maximum power, and we don't fry the wire. Okay, I mean, it's still it'll heat up because the current is there, but it won't overheat and fry itself. All right. Now, with magnetism, you don't have to worry about that. You can send a magnetic flux in opposite directions through iron, and not only will you nix the eddy current, because the eddy current is an indication of wattage, but you do not nix the magnetism. And the reason why is, once you get to the terminus of your iron conduit, that this magnetic flow is flowing in opposite directions simultaneously. Once you get to one end of the terminus, let's put it that way, and you put copper wire alongside of it to pick up the magnetism from the iron and transfer it to the copper, now an interesting thing happens. Now this is all hypothetical speculation on my part, but it makes total sense based on the four inventors that I've named, because they banked on this property. Their inventions have been unriveled. No one has duplicated Nathan Stubblefield's telluric telephony, not even Nikola Tesla. I mean, Nathan Stubblefield was a genius, and yet he was a melon farmer from Kentucky. Self-schooled, self-read, self-taught. But he came up with a magnetic version of electrodynamics that made use of iron and magnetic flux instead of making use of electricity in copper wire. It's a totally different orientation of mechanics, yet it still is AC. It's just not alternating. It's simultaneous. And so when you put copper wire alongside the iron, in which this multitasking, shall we say, or multi-directional magnetism is flowing in opposite directions simultaneously, you know what comes out on the copper end of that transference, that transduction, shall we say, of energy over to the copper from the iron? Alternating current, because the copper can't stand it. The copper can't tolerate magnetism flowing in opposite directions simultaneously, so it forces that energy, that magnetic flux, into a different format, what we know of as alternating electricity. Now, in the iron, the magnetic flux travels simultaneously can travel simultaneously in opposite directions if we induce it that way. Okay, it's mostly gone. Internally to the iron. With aluminum, it's exterior. It gets shoved out of the aluminum. And that's why you'll find that UFOs are always based on aluminum material, because they're shoving it outside themselves instead of internalizing it, such as iron will do. Now, I'm going to give you a few hints. I'm guessing, and it's been my guess for quite some time now, that Nikola Tesla replicated the Amman brothers 10 years after they did, in 1931. They did theirs in 1921. But they had a huge drum filled with iron winding, and Nikola Tesla said, fuck that, I don't need to do that. I'll just go get me a pure Cero that weighs 4,000 pounds, mostly composed of iron, but it also got some glass and rubber, and it's got all that iron mass, and I'll use that. And I won't need to use a massive iron winding and carry it around with me strapped to the front end of the car. And he was right. Because with iron, you don't have to worry about shorting out the magnetic flux. All you need is the mass. See, with copper, you've got to create wire, and you've got to insulate it, and you've got to wind it into a coil, and now you can start worrying about number of turns, and the diameter of the turns, and the mass of the copper, how much copper is there, and the surface area of the wire. To use solid core wire, do you use Lutz, or is it Lutz or Litz wire? I think it's Litz, in which you've got multi-strands of very thin wire, because if you've got very thin wire, bundled within one insulated framework of what we call wire, then you've got more surface area, and at higher frequencies especially, electricity likes to go around the periphery of the wire in a circular, or spiral I should say, a helical fashion, and avoid the core, which is where all the resistance is. And if it's a very high frequency, especially if it's also a very high voltage, it'll get the skin effect, and it'll travel on the outside of the insulation of the wire. It won't even travel inside the wire anymore, because it's too much resistance. Iron and magnetism, though, on the other hand, is a totally different story. The magnetism doesn't find any resistance to its flow in iron. That's why we have magnetic remanence. That's why we have permanent perpetual motion holder. That's why we have core memory of computers between 1955 and 1975, in which once you put the bit or the dit or the dot or the dash, shall we say, the 1 or the 0 memory, depending on which way the flow of magnetism circulated in those tiny little ferrite rings, that computer memory was designed to be composed of. Once you put it in there, it doesn't come out. It doesn't leave until you take it out, and then it's gone from the toroid because you took it out. But it's there forever. It never ceases. And this is iron toroids that are not pre-magnetized. They're just magnetizable. You know, it's not like it's a permanent magnet or something. It's just a ferrite ring. And they magnetize it once, and then it's good forever. It stores that memory of which way the current, the magnetic flux is flowing in there forever. An eddy current is a side effect, that's true, but it doesn't detract from the flow of the magnetism at all. It does lessen the power, you know, it sucks off the power, I suppose, but how can I put this? The magnetic flux never slows down. It never diminishes in force. So it's true we don't want eddy currents, but the interesting thing is that there's a way to get rid of them. And it's a way we've never considered before. Now, how do we make magnetism flow in opposite directions in a strand of iron wire, let's say, or iron rebar? It's a very simple technique. What we do is, you know, when we wind iron, when we wind a perpetual motion holder, usually they use 2 coils, and they say, well, there's a certain way to what do you call it? To orient the 2 coils with each other. You know, each has to be opposite the other because they're on the opposite side of the toroid. So if you bent the toroid, if you cut the toroid at one spot and bent it around straightened it out, you'd see that the 2 coils are wound in the same direction. It's just a matter of perspective. from our perspective, it looks like the coils are wound opposite to each other, but from the perspective of the rebar that's been turned into a toroid shape, it's the same direction. As you go around the rebar, it's always the same, clockwise or counterclockwise, whatever direction it happens to be in. It's the same. But if the two coils are powered separately, or let me put it this way, they're not powered separately. They're the same strand of copper wire, but you wind one way, and then you take the wire to the opposite side of the toroid, and you wind it such that it's the opposite direction. Now, supposedly, we're putting 0 watts into the toroidal circular shape of iron, which means we're not sending any energy into it, unfortunately. But there's another technique to make it happen, and that is to use 2 windings, a bifilar winding, so that, let's see if I get this straight now. So we take 2 strands of copper wire, and we wind 1 coil on one side of the toroid, the iron toroid, and then we go to the opposite side and we wind it such that it's reversed. Now, then we take, now we've got 4 terminals to those 2 strands of copper wire. The terminal we started with winding and the pair of terminals that we finished winding. Now let's just say we take the finished pair of terminals and we connect them together. So now we have 1 copper wire that's bent in the middle, and it's wound, and each half of that or I should say each quarter section of that strand of wire, 2 of those quarters are the middle quarters, the second and the third quarter of the wire, copper wire, and they are facing against each other, and they wind 1 coil one way, while the first and the fourth quarter length of that copper wire winds it the other way on the other coil. And then we hook up the 2 ends to the power source momentarily and power up the iron rebar for just a split second. What have we done? We have sent magnetism in opposite directions simultaneously, because even though the field surrounding the wire, the net result will be 0 watts, there are imperfections in that field because it's 2 separate wires, or I should say it's bent around to look like 2 separate strands of wires. And so in different places, the field is going to be different in different sections of the field surrounding the windings. So it's not going to be a perfect mixing, a perfect neutralization of wattage. It's going to be imperfect. And in each place, it's going to be imperfect in a different way. So the chances of sending power into the iron rebar is enhanced. I'm sure there's a better way to do this. I don't want to tell you the way the Amman brothers did it. I'll let you guess how the Amman brothers did it. They did it perfectly. And let me give you a hint. Expand the number of wires beyond the number 2. And keep making them thinner and thinner to take up the same amount of space, the same mass of copper. It's just increase the number of wires. They're all insulated, and they're running in pairs. One runs because it's a single strand bent in the middle, and we make 2 coils out of it. That increases the chances many-fold, but it still is not the way the Amman brothers did it, and it's not the way Nikola Tesla did it in his Pierce Arrow demonstration in 1931. So I'm not going to tell you everything, but I did give you a little head start, a heads up, that this phenomenon of magnetism is really bizarre. Of course, the crux of the problem is how do we put the magnetism in there, going in opposite directions, if we can't get it to leave the copper wire in the first place? Well, we have to you have to consider how they did it. You see, you have to go to history because, like Eric Dollard said, the research into electrodynamics stopped around at the time when radio was killed. when Marconi invented his version of radio and killed the prior version that was working very nicely. The various versions that those inventors had come up with. Some of them, you know, not the Amon brothers. Well, the Amon brothers were inadvertently creating their radio of their own. In fact, that's why one of them was arrested, because he was disturbing the grid. They claimed he was stealing energy from the grid, but actually he was actually just disturbing it. He was actually powering the grid, but disturbing it at the same time, because their system was working on its set of frequencies and whatnot and phase relations, and the grid was working on a different set, so it created a disturbance. But where they were downtown in Denver, downtown Denver, they were powering everybody. They were powering the grid. But in the foothills surrounding Denver, it was too far away to power, but they were still disturbing it. And so that's where the power went out, not in downtown Denver, but at the fringe, at the perimeter of their radius of influence, which is 10 miles. So they were falsely, the brother was falsely arrested and falsely accused, but it shows that, you know, if government stood up and took notice, if the electric power utility stood up and took notice, then it can't be a hoax. You know, you don't see any article on Wikipedia saying the Amon Brothers electric car hoax. No, instead you see the Nikola Tesla electric car hoax article. All because Peter Savo is not his nephew. So who cares whether he is or not? It doesn't mean the story is bullshit. It just means he's not his nephew. Good grief. Sometimes we take, you know, that's the problem with naysaying cynics. They'll look for one flaw and use that as an excuse for assuming that everything else that goes with it is flawed. And how can you assume that? That's like saying Jesus of Nazareth had to have been perfect, or else if he had one flaw, then the whole New Testament has to be thrown out, the baby along with the bathwater. I mean, yet that's the way Catholicism works, and that's the way science works, unfortunately. We are absolutists. We want everything to be perfect, and if we find one flaw, we throw it all out. And that's a pity and a shame. Now, no research scientist would do that. When you experiment, just because you find one flaw doesn't mean you throw away everything and give up. You say, okay, that was one mistake out of, a mix of mistakes and successes, so let's just keep trudging on and try to reduce our margin of error. You know, come on, you know? I mean, to be absolutists about it and throw it all away, that's so bogus. I mean, that's hideously bogus, and it's a lie. It's an outright lie. Yet we get away with it, and we keep doing it. And that's actually, it's more than prejudicial. It's actually racist. In its own way, it's being racist. You know, finding fault with somebody because of the color of their skin, so they must be dumb, or they're not human. This is what we used to tell ourselves. And this is what we still do. We just do it in a different way. We're racists. I'm sorry, I have to use the word racist. That's exactly what we still do to this day. We just don't do it against black people because it's not socially accepted anymore. But we still do it whenever we get the chance, whenever we can get away with it. I have to say this, it's truth. And as ugly a truth as it is, it has to be stated straightforward with a straight face, just the way it is. And that's what's holding us back. We are still racists, still holding back the progress of information and knowledge because we can't stand the slightest imperfection, and will find fault with anything absolutely on zero ground, or on a fractional ground of evidence.